Okay guys, hello and welcome to a new video. This time the first Road to Las Vegas case from 2026. Yeah, we're in a new season. Yeah, do I have to say something more? Yeah, it was a hard case by our beloved Dim, our champion. And the problem is, Dim isn't that good with my cases. And normally it's also the other way around, which means I'm not so good with Dim's cases. It's the same with Benny and me, so yeah. But anyways, let's jump into it. It's also a little bit differently structured, independent levels, bonus questions that are dependent on level inputs and so on. But yeah, nothing too special. Here, simple XLOOKUP on this table, returning the description. And then you get here down a bonus key, you copy in here, and then this question text is deciphered. And which player has the longest description in the table. And yeah, description is here. Description is here, and you immediately see here 11 is the longest description, and it's by our previous champion, Michael Charman. So level 2, I think this case was written before the AI hype stuff came on. Before the AI hype stuff came on, and therefore it's complicated here, and basically the instructions are inside here. And you either do this not manually or manually, and I will do it manually. So from every word, you take the letter that is in that indicated by this number. So first is an M, U, L, seventh letter is a T, E, P, L, multiply, and then M, I, D, L, E, I, middle, D, I, G, E, T, S, digits, off, no, not if, off, N, U, M, B, E, R, S, multiply, middle digit of numbers. Okay, so text split, and then middle digit is it's T mid, T len of T divided by 2 plus 1, 1. And then we can use the product function to multiply this. Product minus minus, and we're good. So the hardest part here was to decipher the instructions. No bonus this time. Here, level 3. I did a lot of data table stuff, and what you saw here is my macro that is turning this into a esports ready data table setup. So yeah, it's not that hard to do. It's basically making the layout as I'm using it all the time, and it's also independent. So if it's a dependent case, and if I then turn here number 4, it's switching out the example and the sequence based on it. So yeah, that's quite cool sometimes. So case related difficulty skills, challenge, excess of the challenge difficulty. So, and this is like explaining it better, I think. So here you do this for all cases. You have the case rating, you have the player rating for the different attributes, and then you have a challenge. It's basically this minus this, and then min over the array with when it's negative, it's 0, because we only want to have the excess. And then you search the largest, and since you do it for all the cases, you have it then for all the cases. Yes. So basically, I bring in here this for all the cases. Then minus xlookup, lookup for the player number. And the xlookup function can also return multiple rows or columns. And now we can not use max 0 because max is not applying to the whole. It's applying to the whole array and not to the single cells, as you can see here. And therefore I'm mapping this map lambda a max of 0 and a, so to make all negative number a 0, and then by row sum. Quite simple. And then I use here my max lookup lambda, which is basically xlookup and max combined, because with the xlookup you have both a lookup array, lookup value and lookup array, and with max the lookup value is given, and I'm saving there often sometimes. So max lookup is my most used lambda so far. And also you would need to put this in a let to then use it there. So yeah, saving some time. And yeah, we want to return the case name, which is given here. And now I do something else. Instead of using this in the data table, I was able to put it in a single cell. And therefore I'm using it here. Great. Delete this speed. Okay, put it in here. What case is the most challenging for the largest number of players? Okay, since we have it as a formula, we use this formula, go to this sheet, and yeah, then simply copy it in here, and then I will use my count most of value lambda, which is basically in group by. So group by of this count a minus 2 is basically the same as most of value in area, with some additions. But here we want to know the case, I think. Yeah, and the case is Circus Symphony Esports Chronicles. Sounds a lot like ChatGPT or AI generated data. Okay, extract the unique letters in common between each consecutive pair of strings. This one will be data tabled. So first split this, text split, and then we need to know two things. We need to know the previous and the next one to have it in consecutive pairs. I will therefore drop from 1 the last column and drop from 1 the first column, or not drop the last and the first. Yeah, should be switched. Yes. Okay, so here you see I dropped this here, and here it then it was going one up. And now I use count letter in text, and I will explain you this in a bit. So this is the text, and the letter is now the alphabet in vertical direction, and I then can count. I'm able to count the letter here. What is doing? What are both functions doing? So the alphabet is char 64 plus sequence 26. This will turn out the alphabet. And count letter is simply len minus len substitute the certain character against nothing. And the first one is then longer as the second one, as we're substituting out text. And then you have here, for example, there is one E in there. So yeah, that would be that, and then so on. And yeah, everything done in with 2 lambdas here. And this should be the same, or both should be larger than 0. So basically we multiply and count here also in the second term. Yeah, and we then might track this and see, oh, here this is the E and so on. But I want to do this fully dynamic because you see here there are larger and smaller ones. And therefore I use reduce. Do I want to use reduce? No. I first do something else. XLOOKUP for or filter in the alphabet. And here, if this is positive, then it's filtered out. Example for this case. And now I can map here both strings or both arrays in map lambda a b. Doesn't matter. And then I can simply concatenate this. There might be some hiccups, but let's see. I love Excel. No, seems to be that there's every time a common letter. So and now I would normally data table it. So here under data, what if analysis data table, column input, and I would then alternate here this. But I have a macro for this. 61 to 80, B1, B4. And it's doing basically the same as a data table, but without being recalculating. And yeah, there's a bug with data tables I'm quite exposed to, so I try to minimize it. Okay, next bonus level. Bonus 3, the 6 most common letters across all strings in level 6. Spell out a word. Okay, without example. So I first concat this. And then I can use my, one of my lambdas, most of char in area, which then spells out something, and then we would see strong. Or I do it the lame way, the alphabet. Yes. Then substitute and then sort. Which would lead to the same result. So yeah, multiple results, same, multiple ways, same result. Strong seems also to be the solution, since it's not some letters, some letter mix up. So yeah. So level 5. Level 5 was basically, in my opinion, the hardest one. So without a doubt, the hardest one. And yeah, I tried. So first one, when you have, with my current setup, multiple examples, therefore I hate multiple examples. I have here hiccups, but yeah, now resolved. So first, text split of the range, because we have two addresses, RC. And now you could either use row indirect to get the row number, but the problem is this is volatile, and I have a lambda for this based on non-volatile functions, the same for columns, which is making it safer, so to say. So we have here the columns and also the rows, the, let's say, extent. And now I want to use index to output the array first, because it's inside this large chunk. And we're starting at our row cell plus sequence to the extent of rows, starting with 0 to not add also with the first cell something. And then for the columns, it's this plus sequence. Now in column direction, also start from 0. And we have our array, and it's also dynamic and can start here from different cells. So E1 is also in row 1, but at least in a different column, and we still are outputting it from the same, from the right stuff, as you can see here. Right stuff, not that good of an English. So, and then there are different transformations you do. And this is super complicated and took me a while to figure it out. So I basically will show you my way to do this. So you can also read here. So first I took all unique first and second directions. The alternation, that was not that much of an issue, since okay, but hello. So here all 8 different possibilities. Yet let's sort this to have there some order, at least in the first column, and then I basically use 3 operations. I use vertical, horizontal, and mirroring of an array. So vertical means this row is then the first row, and this row is then the last row. Horizontal means if I reverse it or mirror it horizontally, it would look like this. And then there's a third operation, transposing. It's the same as in your math class, where you basically, you switch it on this axis, so to say. I don't know how to explain it in English, so sorry for that. Reverse H, reverse V, transpose. So, okay, and then I make a 1-0 field for all possible operations on it. So, if you do it from bottom to top, or let's start with the easy one, top to bottom, left to right, it's the standard procedure, so to say. So there's no mirroring at all. But if you read it from right to left, you have to mirror it in horizontal way. Vertical still stays the same, and transposing is also not necessary. So bottom to top means first you have to reverse it vertically. No transposing necessary, but you have, for the first operation, you have to reverse it also horizontally. Then left to right, top to bottom, it's only transposing. Left to right, bottom to top, it's vertical reversion and transposing. And then right to left, top to bottom is vertical, horizontal and transposing. And the last one, you do all three operations. So, and I here jump in the cell. And I start with A, with my array. Then I do an XLOOKUP. If, or name this step B. So if XLOOKUP of this and this. Inside the concatenation of this is returning then the reverse. And if this is 1, then I do this operation. I have lambdas for this, I show you shortly. I start with A, vertical 0, horizontal 1, otherwise return A. And nothing happened. So what are the reverse array things doing? You have an array and vertical. If there's a 1, as said, you have it vertical mirrored, and if it's horizontal, then you have it horizontally mirrored, and it can also do both. Yes, that's everything you need to know about this lambda. So see if XLOOKUP of this and this in here and here is then returning reverse vertical, then reverse or array B vertical, not horizontal, otherwise return B, and D if XLOOKUP of this and this in the concatenation of both. So you do an XLOOKUP for 2 arguments, and if there is a 1 here, then we transpose C, otherwise we return C. And I want to output D. So here you then have all the operations, what you do with your arrays. Okay, so far so good. And then there are two ways to solve this. So I went back. I have not thought about, I'll do it that way. I bring in my array in the right direction, and I then starting every time from here. And there are now 2 ways where I do this, how I do this. First row by row, and then with the so-called snake sequence, where you're doing it alternating. And I have a lambda for the snake sequence. I can show you shortly. It was handy in some instances because the snake sequence is not that uncommon in Excel Esports. So yeah, so it's basically a little bit of a sequence concatenation or sequence stuff. But anyways, yeah, I will not do this from scratch today. Faster, please. Sometimes a robot is quite slow. So I have this array here, and I now do the following. I use sort by. I make this array to a single column, and then I make the following to a single column if this says alternated. Then I use snake sequence. The rows and columns are given. Otherwise, I use the regular sequence function, which is then first doing by row, putting out the numbers by row. To coordinate sequence, yes, yes. And I then have it sorted, and I then can simply concat it. Okay, this does not seem to be right. Okay, let me quickly check my original approach. I think that's faster than... It might be that I have switched something. But yeah, how large is the file anyways? Oh, not that large. Okay, level 5. Okay, horizontal, vertical, it's the same. Is this the current one? Yeah. So to be on the safe side, yeah, it's the same. Okay, no issues there. Concat, what am I concatenating? Okay, value error, of course. Also value error. What is on? That is on. Reference error. Okay. Okay, I might only review what was done here. ARR. So reverse a sort by. Okay. So let's make it large. I can close this file here. Hopefully I can let it open. So I here do my index, my array, which is right. Then I do B, XLOOKUP, then A10, otherwise return it, which is also right. Then I do C, reverse array. This should not make a difference. No. Okay, and then I transpose this, which is also right because I have transposed C. So there should not be a difference. And now I do the concatenation of sort by to call off the array. And if this is yes, then snake sequence. Oh, this might be the issue. Because if you transpose it, it might switch the direction. So what I basically want here, snake sequence rows from D, columns from D, sequence rows from D, columns from D. And this will spill. What is wrong? Okay, there's still something wrong, but I don't know what. Is it the horizontal vertical direction? Because here, no, it should be right. Let's copy it in again. No. Okay. Where it is. Here. So array. The array is no doubt is right. Here I reverse it, and then 0, 1. Yes. Then I reverse it from the vertical direction. 1, 0, correct. Then I transpose it, otherwise nothing happens, which is also correct. We might also, let's do the following. Instead of this, output A. And instead of here, CC, output D. I should also be then on this right direction. Okay, here it looks right. Yeah, it's the same. So it has to do something with the concatenation sort by thing. But here, I'm an idiot. I'm an idiot. I have to call D and not A. That was the issue. Okay. Okay. No worries. Okay, now it also makes sense because the first two sentences were not some letter scramble, but some real text. Therefore, I was hesitating. Okay, no thing here. Let's do level 6. So level 6 is, the good thing is with this case, except for level 2, the instructions are crisp. So therefore, first the monkey makes a sequence, a moves based on the sequence. I will not use a lambda here for your sake. So this is basically splitting of the sequence. But he is circling through the sequence multiple times. So I will therefore use a lambda that is stacking up an array. I think it's repeat array. So here, repeat vertical. Let's start with 10 times because it's always doing those directions. And yeah, we then have the movement of the monkey. I could go deeply now here into arrow direction modeling, but what I'm using here is a scan function in combination with this array and one of my lambdas, because for arrow stuff you should use lambdas, cell reference based on reference and arrow array, and it's always using the previous reference and this arrow array, and is then turning out the next one. Yeah, monkey. And you see here it is going from C4 to B5 in that direction, so one down and one to the left, and then down and so on and so on. So yeah, basic arrow modeling like in Esports. Then I have the wolves. And the wolves are interesting. The wolves are doing the following. They try to get as close to the monkey as possible. So there is here this cool indication. They are going as close as possible, always. And how did I do this? I did the following. Cell reference based on reference and arrow array. And I've used my do it independently. So Normally my error array stuff would use the whole array, but now I'm doing it as they would be single steps. And then I use my error list, doesn't matter. It's simply a list of errors. And here I get then all the movements the wolf would make with this with those errors, possible error movements. But you see here there are a few value errors with this hashtag because he's moving out of the borders of the map, because A1 is the first cell, so he can't move up and so on. And then I use toCall 3 to get rid of those. And then I'll do the following. So these are the cell references. And I now use a distance calculation lambda to calculate the distance between the monkey and the possible movements. And diagonal cells are counting as 2. Why are they counting as 2? Because we want to get as close as possible. And if we can move 2 steps, then we move 2 steps, even if this is not bringing us closer. And here we have then the distance. So it's basically comparing the row and the column of not A1 of B5 and all the cells we previously had here, all the cell references. And it's doing this for every cell here. And then you get a distance, row plus column. And not row plus column, because we have here diagonals. Anyways, and then I do an XLOOKUP for the smallest, or in this case 0, lookup in distance, returning CR to get the and now not this movement, this match mode, but next larger if not possible. Now we know the monkey from A1, the wolf from A1 is moving to B2. Yes, he's moving in that direction because it makes most amount of sense. But now something that was a little bit of a trap, it's only for 3 levels of a trap. Sometimes the wolves do not move. And therefore I stack in here also nothing. So do nothing here. I can show you this. CRR, cell reference result, CR. So because a possible movement is now also doing nothing and staying in A1, the starting cell. Because the monkey is sometimes not that intelligent and is walking towards you. And then you can basically track this down and yeah, do this also for the other wolves. No. Okay, why do I have here an error? And you can then basically say, okay, when are the monkeys and the wolves, or is the monkey and the wolf in the same cell? And you have a first through here in cell B7, which is also the answer cell. But now I want to make this 100% dynamic, because we have here multiple wolves, and I'm doing this with a double approach. And my approach here is to use a scan. The initial value is our wolf, and we scan over the monkey movement, wolf start, monkey pause, and here wolf start, and here this is our monkey position. and we have all the movements from the wolves going as close as possible to the monkeys. Of course, we have here, if the monkey is not moving, we're moving into one direction, but if the monkey is not moving because he can't move, it doesn't matter at all. So that's not an issue. But now we have multiple wolves, so I additionally use reduce. Over the splitted array here, lambda a b. Here this becomes not a haystack a, and this becomes b. And I then have a whole array for the wolves. Now I need to get rid of the first column, and I have the movement of all wolves. Now I want to know if there is a cell where the wolves are in the same, or where a single wolf is in the same cell as the monkey, not plus, equal, equal, hello spill, and then I use by row or, and then make a simple XLOOKUP after first time true in here, returning the monkey position. And this now, again, data table, v1, v4. This might take a while because it's a lot of operations. So yeah, we might need to wait here. And yeah, well, I think this level is way easier than the previous one, and it's also interesting because thinking of, okay, how do I move as close as possible to a monkey is also not that easy, and also that you might not move at all at a certain step because the monkey is actually walking towards you is also something to consider. And I hope this will calculate soon, but I think since I'm also recording it in parallel, it is taking too much calc power. But yeah. Hello. I know that it's working. Here we go. Okay, except for one level. Let's see why this is the case. Because we still not have the monkey walking, so I quickly adjust this here. Now we have some value for this, and we quickly copy it in here, and everything is right. Okay, please bonus key. Lana. Our beloved monkey, or it's a love and hate relationship. This is getting slow with this calculation method, but I will turn it off right now. But first we have to do something based on this. So our monkey is starting in this cell here with the sequence given here, and we have wolves in the following cells, and we need to calculate with a large thing, so 40, I don't know. No, 50, come on. Hopefully it's 50. Otherwise, oh yeah, dim 4, 3, 2, 1, go. Funny. Because dim is short for our champ. Or his used name with friends and so on. So I turn off the calculation for the sheet because it's taking a lot of resources, and I go to the last level. Data table, the last level. and we simply want to know something. Who is beating the champion? So first, champion. Then we need to know in which rounds he has participated. Round and also points. Let's do it in one filter. F2, yeah. Okay, LCQR, quarterfinals, semifinals. Then I want to have all unique players in a row, and I then look up for player and the position of first was the round, then the player returning the score. And if he has not participated, then he actually was not able to beat them. So yeah, and since this is fixed, I do not need to model here something, only need to fix those references and can then simply track it here. Really, Sergio has not that interesting. Okay, I hope this is right. Now we need to know when this is smaller than the position of champion, and if this is true, then return the name, otherwise return X. And then to call this, ignore errors, use unique, and we have all people that have beaten them in one of the rounds, and well, there are not that many. So to row, and now we have Ella coming in. We do the same for Ella as for them. Search for her rounds, and we now want to know when do the people, which of those people has Ella beaten. So when has Ella beaten a player that has beaten them? So actually, as she would have beaten them. And I'm trying to do this in a dynamic fashion, at least for this here, because I map lambda a x lookup for the name. This is fixed, and the round, in this case A, in name and round returning the score. Yes, here we have all the scores for so we have here 4 persons. Jack Franken was not in LCQR, so he has 1250 because Ella could not have beaten him. So we have to think in that direction. And then we basically want to know when is the score from Ella larger than the score of our champions? How do I do this dynamic? VStack, no haystack. Since those are dynamic arrays, false, 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 true, and then if this is true, then put out the name, otherwise X, and then the same to call with ignoring errors, also unique, text before, and sort, and concat, and no text join. And we have the solution, and it is a dynamic one. So for example, these are staying the same, but for Ben, he is also only participated in both quarterfinals. Okay, interesting. Also Anop. Okay, so there might be some data issues, but anyways, okay, so we actually should use the if error 0 for all of them. Okay, no issues. Then use the data table, and we have results. Oh, there are a few wrong. Okay, interesting. Andrew and I. No, it should only be Jack Franken. Why is it multiple? Drop haystack. This should be larger than this, otherwise X. But it's the other way around. But he was better. So Andrew Nye has beaten all of them. Okay, what have I done? Jack, Jasper, Jean, Jeremy. Okay, why do I not getting here Jean? Generally, why is Jean not in the list here? Oh, here I am. Jean. Okay. No. Jean Volley. Okay, 1080. Jean should have beaten them. Okay, there's a small issue here. If this is smaller than this, and this stays the same, and for Jean, it's false? No. Cannot be. Or is it? 1080. No, it should be for quarterfinal 1. The draw has more points than dim. So it is, but shifted. Sorry. So if this is true, then output the name, otherwise an X. Now draw is in. Okay. What have I done differently? Nothing, actually. So as you can see here, I will copy this, well, let's say below. And here it's 2 row and 2 column, but this should not change or anything. And the remaining part is 100% the same. So here is draw in. Here he is currently not in. Or he is now. Now we have auto ceremony, which so all 3, which is super weird. Sometimes Excel is not doing what it should do, but yeah. Okay, now we have true false, drop the check, draw. I think this was a weird calculation glitch because the underlying method was not false. Okay. Okay. No, something is super off. Yeah, because I forgot here to include Jeremy. Oh boy. But now. Huh? More levels that are wrong? Come on. 124. So LCQR, Alexander Friedman was better here, so he has beaten Saul. He has beaten Jasper and Jeremy. But Czech was not beaten. Here's the issue. They cannot beat a champ, someone who is not participating. That's the issue. Yes. Okay, it's late now. Everything else. Sorry. DRTST. So a transit world champion is any player who beat the champion or beat someone who beat the champion or beat someone who beat someone who beat someone and so on. So basically everyone is beating everyone, and we now only have to look if someone is for all games the minimum. So here are the players. 2-row unique. Here are the rounds. And we then quickly XLOOKUP. Will this work? I'm interested. Returning the score. If not found, 1250. Yeah, it will work. Great. And then by call min, And if someone is the minimum in all games, then he's not part. Small or equal. And then we use by row and as you can see here, no one is a loser, and therefore everyone has beaten at least one person who has beaten one who has beaten them, and therefore we have 72 as our answer. So a little bit over 1 hour. Hard to do, I think, also since the creator and champion was not able to do it with less than 1 hour or less than 40 minutes. So in the time frame to solve, I think it's okayish. I think especially level 5 is tricky, very tricky. Level 6 actually was decent with my setup, and level 7 we have to think through, but then it's fine. So, well, actually, thank you for attention. I hope you did well in this round. I did okayish, not good, but also not, but I also did worse sometimes. So yeah, thank you anyways. See you next time. Bye.